Okay, so let's look here. So if I wanted to match the graph to a polar equation and a rectangular equation, so let's zoom in a little bit on this graph. So I'm going to start with the circle. Okay, so the center is at 0, 0, right? So the center is at 0, 0, and the radius here is going to be 1, 2, 3. It's going to be at 3. So that will be very easy to write a rectangular equation. So my rectangular equation is going to be x squared plus y squared is going to be equal to a 3 squared. Okay, so my rectangular equation is x squared plus y squared is equal to a 9. All right, so the equivalent polar equation, okay, so remember what x squared plus y squared equals. X squared plus y squared equals an r squared, right? So x squared plus y squared is equal to an r squared. So I can change that x squared plus y squared. I can change this into a r squared, right? Take the square root of both sides because we don't want an r squared, so we'll take the square root of both sides. So we'll get r is going to be equal to 3. So that is my equivalent polar equation. Okay. All right, let's look at this graph here. So this graph is going through the x-axis. Okay, so it's going to go through the x-axis. X equals a 3. Okay, so that is my Cartesian rectangular equation, right? So now I want to put it in polar form. So remember, x is going to be the same thing as r times cosine of theta. So if I say r times cosine of theta, we would say r times cosine of theta is going to be equal to a 3. So you can divide both sides by cosine of theta. So this would be the equivalent polar. So those are equivalent to each other. Okay. All right, let's look at this one. So this one is a polar graph, right? So this is a polar graph, and it's going through pi over 3. So it is theta is going to be pi over 3. So that angle pi over 3. All right, so there is my polar equation. So what can I do to both sides, right? So what can I do to both sides to find a rectangular equation? I'm going to take the tangent of both sides. Okay, so tangent of theta, remember, is y over x. Tangent of pi over 3 is just going to be square roots of 3. Multiply both sides by x here. So my equation is going to be y equals square roots of 3x. Good. All right, let's look here. So now we're going back to a rectangular graph. So this rectangular graph is going to be y equals 3 because it's going through the y-axis. Okay, so when I want to put it in polar form here, so if I put it in polar form, then remember y equals what? R times sine of theta. My dog's sneezing here. So if I want to change the polar, or change it into polar, so we're going to let y be equal to r times sine of theta. Divide both sides by sine, so you'll get 3 over sine of theta. So that is the congruent polar equation to the rectangular equation here. Okay. Alrighty. So let's take a second and look at this one. So it looks like the center is going to be about 1/2, right? So the center is going to be at 1 1/2, right? So the center will be at, well, let's call it 3/2. How about that? 3/2. She is just a sneezing up a storm and a 0. Okay. And what is the radius here? Okay. So the radius is going to be what? 3/2. Okay. So my circle, right, is going to be x minus a 3/2, all of that squared, plus a y squared is going to be equal to a 3/2, all of that squared. So it'll be x minus 3/2, all that squared, plus a y squared is going to be equal to a 9/4. All right. Well, that's not one of the cards, so let's so let's multiply this out. So this will be what, x squared minus a 3x plus a 9/4 plus a y squared is going to be equal to a 9/4. Your 9/4 will go away, so you'll be left with x squared minus a 3x plus a y squared is equal to a 0. So one of the cards is going to look like that. So x squared plus a y squared is equal to a 3x. But if you would have left it like this, I'm okay with that because that is a rectangular form there. Okay. But now we'll be able to change it into polar very easy now that we've multiplied it out. So let's say x squared plus a y squared is equal to a 3x. So when I do that, x squared plus y squared is equal to what? An r squared. And we can change that x into an r times cosine of theta. Okay. So remember, we don't divide, we're not dividing by r, so we need to move that over and factor out that r like we did in one of those problems prior to this. Factor out an r, and we'll have r minus a 3 cosine of theta. We'll set r equal to 0, and then r will be equal to 3 cosine of theta. That is not true because we know our radius is not 0. So those are going to be congruent forms there. Good. All right. So if we look here for this next one, so we've got a y-intercept of, so this is a rectangular one, so we've got a y-intercept of a -2. Yep. And then my slope is rise, so 1 over 2. So the slope is a 1/2, right? So this will be y equals 1/2 x minus a 2. That's not one of my cards, so I'll multiply everything by the 2 to get the fraction out, right? So we'll have a 2y. It's going to be equal to an x minus a 4. When I switch sides here, so we'll move the 4 over here, and it'll be x minus a 2y. Or x minus a 2y will be equal to a 4. So there is your Cartesian, rectangular. So now we want to change it into polar. Okay. So I'll have x minus a 2y is going to be equal to a 4. So remember, x is the same thing as r times cosine theta. Y is the same thing as r times sine of theta. And we don't do anything over here. Okay. factor out the r here. So we'll have r times cosine of theta minus 2, sine of theta. So you'll have r is going to be equal to 4, and then divide both sides by that. So this will be cosine of theta minus 2 sine of theta. So that is going to be a congruent polar form to this linear equation. All right, so that is the card sort. Let me know if you have any questions on that.